Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Okay, this is chapter 8, section problem 108, and this is the big one for the chapter. And the question reads, in April of 2014, in an effort to save money, officials in Flint, Michigan changed their water source from Lake Huron to the Flint River. In subsequent months, residents began complaining about the quality of their water, and General Motors, which has an engine plant in Flint, stopped using the water in manufacturing because of its corrosiveness. That corrosiveness was causing problems that would soon fuel national outrage. The water flowed through pipes to tap in homes, and as it flowed through the pipes, many of which contained lead, the corrosive water became contaminated with lead. Routine monitoring of the tap water in select homes did not reveal the magnitude of the problem because samples were collected only after pre-flushing the tap, allowing water to run for a time. A Virginia Tech professor and his students began an independent test of the water becoming a water coming from Flint's taps and got much different results by analyzing the water that initially came from the tap, the first draw. Their results, which showed elevated lead levels in the tap water, ultimately forced officials to switch back to the Lake Huron water source. The following table shows a set of data collected by the Virginia Tech team. The lead levels in the water are expressed in units of parts per billion, ppb, and 1 part per billion equal to one gram of lead for 10 to the ninth parts of solution or grams of solution. Examine the data and answer the questions that follow. Okay, so they gave you some data, and I do have it typed here. I have it zoomed out a little bit right here, and along with the calculations already performed. So A asks you the following. Determine the average value of lead for first draw, 45-second flush, and the 2-minute flush, round to 3 sig figs. So, okay. So here I typed in the table from the textbook. We can see it here. The first draw values are on average 10.3 parts per billion. After a 45-second flush, that goes down to 3.81 parts per billion of lead, and after 2 minutes, it drops down to 1.69 parts per billion. Okay. Do the data support the idea that running the tap water before taking a sample made the lead levels in the water appear lower? Why might this occur? Yeah, absolutely. So again, the parts per billion went from 10.3 out of the initial draw to 3.81 down to 1.69. And clearly, the corrosive water that sitting in these lead pipes right before the faucet is turned on, it's dissolving more and more of the lead as the water runs. That lead is entering into your shower, into your glass, whatever, and then followed by more fresh water that has less time sitting with those lead pipes. Okay. C, the EPA requires water provide the monitor drinking water at customer taps. If lead concentrations exceed 15 parts per billion in 10% or more of the tap samples, the water provider must notify the customers and take steps to control the corrosiveness of the water. If the water provider in Flint had used the first draw samples to monitor lead levels, would they have been required to take action by the EPA requirements? If the Flint water provider used 2-minute flush samples, would they have had to take action? And basically, the 2-minute flush really did work. And there were 3 out of 15 of the samples that they collected were above 15 parts per billion. Let's say we've got 40.63, we have 29.59. I thought there were 3. 1, 2, 3. Oh yeah, 40.63, 24.37, 29.59. So that's 3% of the samples because there were 15 samples. There were no samples above 15 parts per billion after the 45 seconds, and definitely none after 2 minutes. So clearly, you would hope that people would wait a full 2 minutes or 45 seconds before using that water, but I wouldn't expect it to happen each and every single time, which is dangerous. Okay. And then finally, D asks us, using the highest value for the lead from the first draw set, which is 40.63, And assuming a resident drinks 2 liters of water per day, calculate the mass of the lead that the resident would consume over the course of 1 year. And it tells you to assume a density of 1 gram per milliliter. Okay, so if we've got 1 year and 365 days per year and 2 liters a day, if we can convert that to milliliters per year of water consumed, and then we can convert that to grams of water consumed per year. And then they give us the parts per billion, so it's 40.63 grams per, and that's milligrams per liter, or we can say that's per 10 to the 9th gram of solution. So we multiply that by 4 times 10 to the minus 8 to convert that to grams, and then what's that last one? Oh yeah. So this last one is the whole calculation. I was like, what's that last number? That's the answer. So our final answer is 0.0297 grams of lead per year, which is not a small amount. I mean, I don't know. What, 5 grams is a nickel? But yeah, so that's how you answer this large question. It's a little bit of dimensional analysis, a little bit of unit conversion, taking averages and stuff. And that's it for chapter 8.